Alrighty, we're going to start looking now at area. So area, as we've talked about in previous videos, talks about how much space a shape takes up, and we count it in square units. So if the sides of this are 1 centimeter each, then we say that this area in here is 1 centimeter squared. If you have a little square with side lengths of 1 millimeter each, then the area inside there is 1 millimeter squared. And we've talked about converting between these units before as well. You can see it's going to take a lot more than 10 millimeters squared to fill up 1 centimeter squared. In fact, it's going to take 100. So we're not just multiplying by 10 if we want to convert. We have to multiply by 10 squared, okay, by 100. Fit 10 across the bottom, 10 up the side, and fill the rest in, so 10 by 10. Anyway, here are the important rules that we use. We have some examples here already filled in for some common shapes that we have. There's going to be another video with more complicated examples. Alright, so we have a square. Right angles equal side lengths, quadrilateral. Its formula is length squared, or you can think of it as length times width, just that the length and width are the same. Here's an example. Square with 4 meter side lengths. You set it up, the area is length times length, so 4 times 4 is 16, and remember your units. Rectangle. Here's our formula, length times width, that's what it looks like. Pretty straightforward. We know these very familiarly by now, so 6 by 3 length times width, and 18, and our units centimeters squared this time. Remember squared units for area because of those squares. Okay, triangles. We've got 2 versions of the formula here, and in our diagram we're showing what counts as the base and what counts as the height. Now basically the base has to be perpendicular to the height that we are given, so it won't necessarily be at the bottom of the shape. This one is, but note that the height that we're using has to be perpendicular. So have a look at our example here. Here we have a base, or a side is 4 millimeters. This one's 5 millimeters, that one's 3 millimeters. And we've got a height here of 2 millimeters. Notice that this one and this one are perpendicular. That means that this is our base and that is our height. So those are the 2 numbers that we're using. This 5 millimeters and 3 millimeters are not relevant when we are finding the area, but they would help us to find the perimeter if that's something that we wanted to do in this shape. Area, so base times height over 2 using this formula here, and our units. Rhombus, it's like a squash square, equal side lengths, opposite sides parallel. To find its area, we use the diagonals of the shape. So this length here, represented by this arrow outside, and this diagonal here, represented by this arrow on the outside. And in our example over here, we have how it is shown again. Here's our formula. So x times y, our diagonals multiplied by each other, all divided by 2. Have a think about why that works. You can actually see that in this, you've got this x times y. That would be this big rectangle here. Why are we dividing it by 2? Why aren't we using this whole rectangular area? Riddle me that. I'm sure you can see. So again, our example over here, so 6 times 5 over 2, and our answer and our units. A very familiar pattern by now. Parallelogram. The area is the base times the height. Here is our base. Again, our height is perpendicular to that as shown. What this little dotted line here is doing is showing why the formula works. So if you imagine, you can cut off this triangle, move it over there. This should be exactly the same size as our other triangle. So imagine you just cut this bit off, put it over there, then you're going to have a rectangle, and it's going to be as long as the base and as tall as the height. So it's like our length times width formula works for that. Okay, so base times height, again, remembering that the height is perpendicular. So in our parallelogram here, we want the 8, we want the height that's perpendicular, so that's 4. We do not care about this slant height here, there's 6, nothing to do with finding the area. It's called a red herring. just extra information. 8 by 4, 32 meters squared. These formulas are all on your formula sheet. Trapezium. All right, two different ways of writing it. Basically, what you're doing is you have your two parallel sides, you add them together and divide by 2. That's what this is showing you. Add your two parallel sides together, divide by 2, and then multiply all of that by the height. Or instead of writing it like that as one fraction, you can say, oh, dividing by 2 is like a half of it. So you can find a half of your two sides there added together and then multiply that by your height. If you want to see why this works, have a look. I think it's the last textbook question. I've put it in as an extra one for this week. All right, and here is our example. Again, looking at the diagram, which information do we actually need? Those two parallel sides. We should have marked in that those were parallel, and we should also mark in that this is perpendicular. So we want those two sides, that's our A and B, so our 3 plus 6 over 2, and then our perpendicular height, which is 4. You can write this line and then put it straight in your calculator and get your answer, if that's how you prefer to do it, but we do definitely need to see at least you're setting up your working. All right, these are going to be in a different video, but I did want to show you a couple of extra skills that you're going to need for this exercise as well. So sometimes we are asked to work backwards. So you're told what the area of the shape is, you're told what kind of shape it is, and you're asked to find out something about the dimensions. So this is just using your algebraic rearranging skills for the formula, basically. So here's our example. If the area of a rectangle is 18 centimeters squared and the width is 4 centimeters, what is its length? So we know that a rectangle has the formula area equals length times width. We know that the area is 18 centimeters squared, so that's 18. And we know the width is 4. So 18 equals the length times 4. And we want to know what is the length. You'll see we have an equation here that we've created with only one unknown. So now we jump into algebra mode. All right, we want to find L. It's being multiplied by 4. We want to undo that, so we're going to divide by 4 on both sides. 18 divided by 4 is 4.5. 4.5 equals L. We can write a little worded statement there. Therefore, the length is 4.5 centimeters. If you're not going to write this, you should at least put centimeters here. If it's a worded question like this, you're better off writing something short like that, just in case. Okay. Next thing, check your units when you're doing your calculations. In order to calculate areas, all of your lengths must be in the same units. Always do that check. Sometimes it'll be obvious like this. You go, really, is that 1.2 and that's 90? That doesn't sound reasonable. So you check, like, oh, okay, this one's meters and that one's centimeters. All right. This is asking you to calculate the area of the shape in centimeters squared and in meters squared. And we're going to do an estimate first. So about how big do you think this is? Well, I'm looking at this and going, well, that's almost a meter. That's a bit over a meter. So it's about a meter by a meter. This one's a little bit longer than that one is short. So just over a meter squared is what I'm expecting to get. Now, there are a couple of ways of getting the area. So I'll show you two options. Option 1. You can change everything into the same units. So let's say that this is equal to 120 centimeters. Well, actually, you have to make them the same units regardless. So option 1, convert area at end. Okay. So we've got centimeters and centimeters. So our area is length times width area is, you just notice what's wrong with my diagram. I'm saying that these are equal sides and they're clearly not. Let's make that look like a rectangle. So length times width, 90 by 120 is 10800. These were my centimeter units. So centimeters squared is what I'm getting as the answer. Alrighty, so we've got our answer for centimeters squared, and we can use this, as I'm saying, to convert the area to meters squared, because that's the other one we want. In meters squared, I'm just saying what I'm doing. So in meters squared, that's going to be equal to 10800 centimeters to meters. We're using that 100, right, because there's 100 centimeters in a meter, and we are dividing by it because we're going to the bigger unit, and we're using area, so we're squaring that. So I'm going to have that divided by 100 squared, which is 1.08 meters squared. All right, remember we estimated it's going to be just over a meter or around a meter squared, so that's perfect. I figure that's a reasonable answer. Okay, your other option, instead of using the area that you've calculated and then converting units, is you can go back and start again and change this one into meters. So converting all of your units at the start, convert lengths. Converting all units at the start means that you're not having to convert areas and volumes, which is where people often make mistakes, as we've talked about before at start. So I'm just finding meters squared now, because I would have just done this to find centimeters squared, and now I'm finding meters squared. So I'm going to have area equals length times width, 0.9 times 1.2. I already know what it's going to be, but let's just check. There we go, 1.08. Because both of these were in meters, that's going to be in meters squared. All right, often when you are given units, given like a diagram, say everything's in millimeters, and you want your answer to be in meters squared, easiest thing is to convert first. Okay, that's it.